We are going to move on to section 3.4 today. Section 3.4 is solving multi-step inequalities. Now, the good thing about solving multi-step inequalities, as you may have guessed, is it's pretty much the same thing as solving multi-step equations. Other good thing today is we're just going to solve the inequalities. We're not going to worry about graphing them. No, you can graph these, but we're just not going to graph them today. So that first little note there, we're going to use the same methods as we do to solve equations, but we do need to remember what we talked about on Friday, that if you ever multiply or divide both sides of the inequality by a negative number, you have to flip that sign, okay? So that's the big thing we're looking out for today. So let's get started on some examples. Number one, if I have 5f plus 7 is less than or equal to 22. So to kind of get us back in the hang of solving inequalities and equations, remember I gave you that onion method. So just to review the onion method, if that's something that you wanted to use, we always circle the variable first, and then we circle the operations in PEMDAS order. So 5 times would come next, and then I would add 7. So as hopefully we know, the first thing that I need to get rid of is the plus 7. So we would subtract 7 from both sides. So I'd have 5f is less than or equal to 15. And then to get rid of the 5, we would divide both sides by 5. I'd have f is less than or equal to 3. Once again, we can graph this. We're not going to worry about graphing them today. We're just going to be solving. Okay, let's try another one. Number 2. 9 is less than or equal to negative 12 plus 6r. Okay, so whether you use the onion method or you just kind of know that negative 12 is the first thing that we need to get rid of. So to get rid of a minus 12 or a negative 12, we're going to add 12 to both sides. So I have 21 is less than or equal to 6r. And then to get rid of the 6, we're going to divide both sides by 6. Now it's not going to go in evenly, so you could either change it to, we definitely need to simplify, so I could divide out a 3 from both of those. And I'd get 7 halves. You can either leave it as 7 halves, you could change it to a mixed number, you could change it to a decimal, or just leave it as 7 halves. Now, although we're not graphing these, if you remember, I talked about it's really good practice to write the variable first. So even though we're not graphing it, once again, I'm curious about what r is. I don't really care about the 7 halves part. I want to know about r. So let's go ahead and let's get in the good habit of rewriting them so that the variable comes first. So my final answer should be r is greater than or equal to 7 halves. Okay, number 3. Negative 5y minus 2 is less than 8. Okay, kind of like the last ones, that minus 2, that's the first thing that's got to go, so we're going to add 2 to both sides. So I have negative 5 is less than or equal to 10. Now to get rid of the negative 5, we're going to divide both sides by negative 5. Now this is like those big red blaring alarms here. See how I divide both sides by a negative number? That's where you've got to watch out for these, and I've got to flip that sign. So instead of being a less than, that's going to flip around to a greater than. And 10 divided by negative 5 gives me negative 2. That's the big, big thing you have to watch out for today. If you multiply or divide both sides of the inequality by a negative number, you have got to flip that sign. Always be on the lookout for that. Okay, let's look at one that's maybe a little bit tougher. Number 4 is 3 times the quantity k minus 5 plus 9k is greater than or equal to negative 3. So kind of got a lot going on here. The first thing, let's go ahead and let's get rid of those parentheses. So we're going to do that by distributing. So I have 3k minus 15. And then I've still got the plus 9k is greater than or equal to negative 3. Notice I didn't distribute the 3 to the 9k because the 9k wasn't in parentheses. Okay, next, before I start moving stuff all over the place, let's go ahead and let's combine like terms. 3k plus 9k, since they're on the same side, just add them together. That gives me 12k minus 15 is greater than or equal to negative 3. I need to get rid of the minus 15, so we're going to add 15 to both sides. I have 12k is greater than or equal to 12. And then finally, divide both sides by 12. We should have k is greater than or equal to 1. Okay, like I said, just pretty much the same thing as solving an equation. Just watch out for those negative numbers, multiplying or dividing both sides by a negative number. Okay, let's try this one, number 5. Negative 3 times the quantity j plus 3 plus 9j is less than negative 15. Kind of like the last one, to get rid of those parentheses to begin this process of simplifying, let's distribute that negative 3. Now you have to be careful. Make sure you distribute the negative 3 to both places. So I have negative 3j minus 9, and then a plus 9j is less than negative 15. Let's go ahead. Let's make sure both sides are simplified, so I can combine those j's together to give me 6j minus 9 is less than 15. And then to get rid of the 9, we add 9 to both sides. So I have 6j is less than negative 6. Divide both sides by 6, and I get j is less than negative 1. Now, before we move on to the next one, I want to point out that I did divide by a negative number here, but since this 6 is positive, I don't have to flip the sign. Only if you multiply or divide both sides by a negative number do you have to flip the sign. Okay, let's try number 6. 3m minus 4 is less than or equal to 6m plus 11. Now I want you to notice on this one I've got m's on both sides of the inequality symbol, so just like whenever I was solving equations, the first thing I need to do is I need to get them in the same place. So we're going to subtract 3m from both sides, and then that leaves me with negative 4 is less than or equal to 3m plus 11. And now it's just a two-step inequality, so subtract 11 from both sides. I have negative 15 is less than or equal to 3m. And finally, divide both sides by 3. Once again, it's a positive 3, so don't worry about flipping that sign, but it is going to be a negative 5 is less than or equal to m, which, remember, if the variable is not written first, we want to get in that good practice of flipping that around. So my final answer should be m is greater than or equal to negative 5. Okay, we're about halfway done, but we're going to look at some that end up having a little bit different kind of answer. So number 7, negative 3 times the quantity w minus 3 is greater than or equal to 9 minus 3w. Okay, kind of like the one, not number 6, but number 4 and number 5, we need to distribute. Be careful, make sure you distribute the negative both places along with the 3. So I get negative 3w plus 9 is greater than or equal to 9 minus 3w. Notice I've got w's on both sides, so to get them in the same place, we add 3w's, because notice both of those are negative 3w's. Now if you notice, my w's cancel out. Now just like with equations, it is important that my w's cancel out, but what is even more important is what I'm left with. And if you look at this, I'm left with 9 is greater than or equal to negative 9. And just like an equation, I'm asking myself, is that true? Well, yeah. 9 is greater than or equal to a positive 9. So just like an equation, my answer would be all real numbers. Exactly like an equation. Let's try another one kind of like that. Number 8. 6m minus 5. Hold on, 6m minus 5 is greater than 7m plus 7 minus m. Now if you notice over here on the right side, I can combine those m's together. So the left-hand side, let's leave it as 6m minus 5, but 7m minus m gives me 6m plus 7. Just like the last one, I've got m's on both sides of the equal sign, so since those are both positive 6m's, we're going to subtract 6m from both sides. Just like the last one, the m's cancel out, and just like the last one, that is important. What I'm really interested in is what's left over. Now on the left-hand side, notice I'm left with a negative 5 is greater than 7. Now this time, if you think about that, negative 5 greater than 7, that's not true. And so just like an equation, if it's not a true statement, that's going to be a no solution answer. There's not a single number that you can plug into that inequality and it's going to work. Okay, let's try number 9. 2 times the quantity n minus 8 is less than 16 plus 2n. Okay, first thing, hopefully you're getting the hang of this. I need to distribute. So I have 2n minus 16 is less than 16 plus 2n. Once again, I've got n's on both sides of the equal sign. So to get rid of those, I'm going to subtract 2n from both sides. And see how they cancel out again? Once again, I need to know what I'm left with. Now I'm left with negative 16 is less than 16. You're going to have to pay really close attention to those signs because that negative sign is still there. So now we ask ourselves, negative 16, is it less than a positive 16? Well, yeah, it sure is. Okay, so we're going to say all real numbers. Okay, I just have a few more. Okay, number 10, say I have negative 3 times the quantity x minus 3 is greater than or equal to 5 minus 4x. Okay, we're going to distribute that negative 3. I have negative 3x plus 9, because negative 3 times negative 3 gives me a positive 9, is greater than or equal to 5 minus 4x. Okay, like the last ones, I've got x's on both sides of my equal sign. If we're looking for positive numbers, we're going to move this minus 4x over here to the left-hand side, and we're going to do that by adding 4x. Okay, so negative 3x plus 4x, well, that just leaves me with a positive x, and I've got plus 9 is greater than or equal to 5. And then this one's not too hard to finish out. Subtract 9 from both sides, so I have x is greater than or equal to negative 4. Okay, 2 more. Let's look at number 11. Okay, number 11, 4 times the quantity a minus 2 minus 6a is less than or equal to negative 9. Okay, we need to distribute that 4 to the a and the negative 2. So I have 4a minus 8. I've got the minus 6a that's separate. Remember, we don't distribute that 4 to the negative 6a because it wasn't in the parentheses. Okay, make sure you simplify before you start moving things around. 4a minus 6a, that leaves me with a negative 2a minus 8 is less than or equal to negative 9. Okay, now I have a two-step equation, so I'm going to add 8 to both sides. So I have negative 2a is less than or equal to negative 1. And I'm going to divide both sides by a negative 2. And hopefully those blaring sirens are going off in your head because I just divided both sides by a negative 2, which means I have to flip that sign around. So now it's a greater than or equal to sign. On the right-hand side, I have negative 1 over negative 2. Well, a negative divided by a negative is going to turn into a positive answer. So my final answer should be a is greater than or equal to a positive 1/2. Okay, last one here, number 12. 17 minus the quantity 4k minus 2 is greater than or equal to 2 times the quantity k plus 3. Okay, so we're going to have to be kind of careful on this one. Kind of got a lot going on. On that left-hand side, I need to distribute, but the only thing I'm distributing is that negative sign. Not the 17. This is 17 minus, so I'm just going to distribute the negative sign. So I have 17 minus 4k. When I distribute a negative to a minus 2, it turns to a plus 2. On the right-hand side, I have to distribute the 2, and I get 2k plus 6. Okay, let's combine like terms. On the left-hand side, I've got the 17 and the 2, which gives me negative 4k plus 19 is greater than or equal to 2k plus 6. Okay, next I've got k's on both sides of the equal sign, so you can really move them either direction, but for me, I'd like to work with positive numbers, so I'm going to move that negative 4k to the other side by adding 4k. So I have 19 is greater than or equal to 6k plus 6. And to finish this one out, we're going to subtract 6 from both sides. Okay, and I end up with 13 is greater than or equal to 6k. And then finally, divide both sides by 6. You can leave your answer as 13 over 6. If you really want to change it to a mixed number, you can. Or if you want to change it to a decimal, you can. Or leave it as 13 over 6. So I've got 13 over 6 is greater than or equal to k. But remember, since we're super awesome, incredible students, we're going to rewrite our answer in terms of k. So the k comes first. So I have k is less than or equal to 13 over 6.